Greetings everyone, I'm Jeff Woolsey, Principal Program Manager in the Azure Edge and Platform team, and I'm excited about our session today, Microsoft Azure Stack HCI. Given what's been going on in the world, it seems like a good time to remind you of our mission at Microsoft, to empower every person and every organization on the planet to achieve more. The last couple of years have been challenging to say the least, and we've seen it firsthand. Satya Nadella sums it up this way. We've seen 2 years worth of digital transformation in 2 months. From remote teamwork and learning, to sales and customer service, to critical cloud infrastructure and security, we are working alongside customers every day to help them adapt and stay open for business in a world of remote everything. Across the world, customers are running hundreds to thousands of applications across diverse infrastructure in multiple programming languages, across multiple different environments, different public clouds and private cloud infrastructure. There's a wide variety of different ways that people are building their apps into various different environments. If you look at many of our customers' environments today, it's clear that they continue to grow in complexity with the influx of new technologies and platform investments, as customers deploy into more hybrid and multi-cloud environments. To add to this complexity, your teams are using different development tools, languages, and frameworks, as well as approaches like open source, Kubernetes, and DevOps. At Microsoft, we have long understood this reality, and Azure and the Microsoft Cloud strategy has been designed with hybrid in mind from the very beginning to help meet these challenges. As we have conversations with customers and ask, what's top of mind? We hear some common themes. Customers tell us, we want to manage our infrastructure at scale across distributed environments while ensuring security and compliance. We want to manage our cloud and on-premises infrastructure in a consistent way, leveraging existing tools and skill set. We built cloud apps that now need to run on-premises and at the edge. We tried deploying and managing our own Kubernetes on-prem, and it's challenging. How do we do this? We want to bridge your on-premises infrastructure with the cloud in a cost-effective way. We want to reduce complexity with fewer moving parts and deliver new applications and value faster. So while cloud growth continues at a very rapid pace, we're also seeing that IT services are expanding at the edge. In a recent survey, about 80% of organizations are planning to deploy more IT services at the edge. Many cited that they want to deploy equipment in close proximity to where it's needed, like the factory floor, in medical facilities, in retail locations, and more. There is a clear need for services at the edge. In another recent IDC survey, IDC found that top areas of budget savings were attributable to HCI deployments. HCI tends to be simpler to manage than a traditional rack of servers and bespoke SAN solution. SANs are complex, costly, and require specialized training. Another area was the capital cost of the SAN. In many cases, customers are sunsetting traditional SANs in favor of HCI solutions loaded with local storage and often coupled with a significant performance boost. As more devices expand at the edge, it magnifies the issue of managing distributed systems at scale. This takes us back to what customers keep telling us. We want to manage our infrastructure at scale across distributed environments while ensuring security and compliance. We want to manage our cloud and on-premises infrastructure in a consistent way. We've built cloud apps that now need to run on-prem and at the edge. How do we do this? How can we deliver new applications and value faster? We believe consistency, uniformity, and integration leads to operational efficiency. Azure Stack HCI is an Azure service. It is delivered by the Azure team. The same team that builds and deploys the Azure host, builds and delivers Azure Stack HCI. The team that includes Azure Arc, Azure Kubernetes Service, Azure Data Services, Azure App Services, Azure Machine Learning, Azure Insights, Azure Log Analytics, Azure Virtual Desktop, and I could go on and on. We are all one massive team. Whether our customers need to run on-premises, hybrid, multi-cloud, or at the edge, we want them to create secure, future-ready cloud solutions on Azure. Now, speaking of customers, 95% of the Fortune 500 use Azure. Organizations like PepsiCo, Virgin Atlantic, the American Cancer Society, SKF, Bosch, Goodyear, Kainos, the Make-A-Wish Foundation, and you can see thousands more at www.azure.microsoft.com. As our CEO Satya Nadella has said, our mission is to empower every person and every organization on the planet to achieve more. Whether it's creating new apps with app services, Power Apps, functions, AKS, deploying new Cosmos or SQL databases, monitoring the health of your digital estate, or securing your organization, Azure customers start here at the Azure Portal, and Azure Stack HCI is no exception. Azure Stack HCI is an Azure service. This means when you register Azure Stack HCI, and that takes about a minute, it automatically appears here as a resource in the Azure Portal. Not just one, but all your Azure Stack HCI deployments are displayed here alongside your Azure resources. Let me show you. Let's get started here in the Azure Portal. You can see in the recent resource list that I have several Azure Stack HCI clusters, including some in Atlanta, Boston, Texas, and a brand new Azure Stack HCI cluster in Seattle called Alltail HCI Cluster. Clicking on this cluster, you can see this is a 4-node Dell PowerEdge R630 solution. Let's click on the first node of this cluster. If I wanted to add capabilities to this specific node, I can do that here. You can add capabilities like update management, logs, monitoring insights, policy, security, and more. However, in this case, I'd like to add capabilities to the entire cluster. Better yet, I want every node in the cluster to have all the same capabilities and ensure there's no configuration drift. Let me show you just how easy this is with Azure and Azure Arc. Let's go back to the full cluster and add capabilities to the entire cluster. All I need to do is click on Capabilities and click below on Logs. Now I enter my Azure Workspace information, click Add, and Azure Arc will configure every single node in this cluster to collect logs to support monitoring and other insights. I don't need to log into every node to install or manage agents. Azure Arc handles all of this and even monitors for configuration drift. If I need more capacity and decide to add another node to the cluster in the future, Azure Arc will automatically add and configure the new node to match the configuration of the existing cluster. This is game-changing hybrid cloud management. Now let's type in Monitor in the Azure Portal and look at the rich set of Azure monitoring services and insights available. Notice here in the left-hand column there are insights for virtual machines, storage accounts, SQL, and the new option for Azure Stack HCI right here. Clicking on this, you can see 4 clusters in Atlanta, Boston, Texas, and Seattle. Now my Alltail cluster is new, so there's nothing running on it yet. You can see all these clusters, including my 3-node cluster in Atlanta, are all healthy. If I want to view my VMs, click on Virtual Machines, and I can see all my virtual machines and all my selected clusters, even though they're running in 4 different cities. If I want to view overall storage health and performance, click on Storage, and you can see I have a total of 12 volumes, 64 total drives. All the drives are healthy, their size, and their usage. If I want to drill into a specific volume in a specific cluster, like this one in Atlanta, I can see IOPS information, trending info, throughput info, and all of this in the Azure Portal. If I want to view overall cluster performance, I can see CPU usage, volume latency, IOPS, throughput, and compare this with the other Stack HCI solutions in one view. I hope this quick demo shows you what you can achieve with Azure, Azure Arc, and Azure Stack HCI working together to give you the best in manageability and visibility for your overall estate. Let's take a closer look and highlight a few things in that demo. Let's start with Azure integration built into Azure Stack HCI. There are no agents to install. No messy scripts to run. This is all automatic and transparent. Azure Arc is built into Azure Stack HCI. Next, the Azure Stack HCI resource displays all the nodes of the cluster, including manufacturer, model, compute capacity, OS version, and standard Azure features and controls, which I'll show in a second. Next, cluster-wide capabilities. Because an Azure Stack HCI cluster is an Azure resource, you can assign capabilities to the cluster like Log Analytics or Azure Monitor. This capability is a property of the cluster, so if you add more nodes to the cluster, they will automatically be configured with these capabilities to ensure uniformity for every node in the cluster. In addition, Azure monitors for configuration drift, so you don't have to. Azure Monitor helps you maximize the availability and performance of your Azure Stack HCI clusters. It delivers a comprehensive solution for collecting, analyzing, and acting on telemetry from your cloud and on-premises environments. This information helps you understand how your HCI clusters are performing and proactively identifies issues affecting them and the resources they depend on. With monitoring added to my cluster, here you see multiple Azure Stack HCI clusters in different cities, all in one view. You can also drill into a specific cluster to see individual node status, or click on all the drop-down arrows to see all the nodes for all the clusters and their health status in a scrollable list. Once you enable Azure Logs and monitoring for your clusters, Azure can aggregate the data and present it with visualizations from multiple clusters to deliver Azure Stack HCI Insights. Azure Stack HCI Insights provide health, performance, and usage insights about registered Azure Stack HCI clusters that are connected to Azure and enrolled in monitoring. Azure Stack HCI Insights stores its data in a log analytics workspace, which allows it to deliver powerful aggregation and filtering and analyze data trends over time. Now, there is no direct cost for Azure Stack HCI Insights. Let me say that one more time. There is no direct cost for Azure Stack HCI Insights. Users are billed based on the amount of data ingested and the data retention settings of their log analytics workspace. Azure Stack HCI Insights offer three primary benefits. Number one, it's managed by Azure and accessed from Azure Portal, so it's always up to date, and there's no database or special software setup required. Let's compare this with traditional systems management for a moment. If you wanted to do this on-prem, you'd have to set up complex infrastructure, systems management, deploy agents, make it highly available, and manage the end-to-end lifecycle for this management and rinse and repeat with every new systems management release. You don't have to do any of that with Azure Stack HCI. Microsoft manages all of this complexity for you. Pretty cool. Next, it's highly scalable, capable of loading more than 400 cluster information sets across multiple subscriptions at a time with no boundary limitations on cluster, domain, or physical location. It's also highly customizable. The user experience is built on top of Azure Monitor Workbook templates, allowing users to change the views and queries, modify or set thresholds that align with the user's limits, and save these customizations into a workbook. Charts in the workbooks can then be pinned to Azure dashboards. If you want to know more about Azure Stack HCI Insights, go to aka.ms/hci-insights-docs. Now, one topic we haven't discussed yet is support. So let me show you some of the other benefits of Azure Stack HCI as an Azure service. Let's start with access control. This is a standard, important control in Azure. Here you can view roles, you can grant or deny access to resources, or simply check access. Now, my colleague Cosmos Darwin needs to access this cluster a little bit later, so I'm going to confirm he has access so he's not blocked, and we're all good. Next, we have tags. Tags allow you to easily categorize your resources. This is useful for billing, like department codes, and can be used for a variety of scenarios. I like to tag clusters by city, so I'm going to add Seattle and apply this to the cluster. And again, this is my Azure Stack HCI cluster. Now, just like any Azure service, Azure Stack HCI has built-in diagnostics where you can review common issues, you can review common questions. And of course, if you don't find a solution, no problem. Because again, this is all Azure. So you can create a new support request right here for your Azure Stack HCI in the Azure Portal. So I want to know more about Kernel Soft Reboot. So these support requests are managed through the Azure Portal and covered by a dedicated Azure support team. Unlike other HCI vendors, there's no separate support contract is required, and it doesn't depend on how many clusters you have. If you have Azure support, you have Azure Stack HCI support. Now again, I want to know more about this cool kernel soft reboot feature, so I'm looking for guidance, and I found it. I'm going to show you more about this sweet new feature, kernel soft reboot, a little bit later. Now, to lower IT OpEx, one great feature is the ability to provide self-service. In this scenario, IT delegates access to a user who can create resources like VMs, but can't access the underlying infrastructure. For example, suppose a developer needs to access to test an app at the edge on Azure Stack HCI. Wouldn't it be great if you could use the same VM creation process in Azure with Azure Stack HCI on premises too? That way you don't need to train someone on a completely new and different process. Again, consistency leads to efficiency. Well, let's take a look at VM self-service with Azure Stack HCI with my colleague Kilol.
Hello everyone, I'm Kilol Subjan. I'm a PM on the Azure Stack HCI team, and I'm excited to share updates on Arc-enabled hybrid capabilities that we are bringing to your on-premise Azure Stack HCI cluster. Today we will talk about VM self-service, which allows application owners and DevOps teams to autonomously deploy and manage their applications without the need to manage the underlying hardware. Let's see how. We start with a custom location created for an Azure Stack HCI cluster. As an admin of the cluster, I've set up a resource bridge on the cluster, which helps in projecting my HCI cluster as a custom location onto the portal. And from the IAM page of this custom location, I can assign or remove access controls for specific groups or individuals. So here I'm going to add Jeff as a contributor on this custom location. And that way, he has the permissions to perform VM operations for this custom location, or in other words, he will have the permissions to perform VM operations on the underlying HCI cluster. So let's go ahead and add Jeff. And there we go. We would have added Jeff. So every user or group who has been granted access on this custom location can now create VMs, manage them, perform any operations such as start, stop, restart on the HCI cluster without having to manage the cluster itself. Next, we go to the VM creation blade, and you will notice a familiar Azure Portal-based VM creation workflow, where users can provide basic information about the resource group, the subscription where they want the VM to be, and they should be good to go. So let's go ahead and do that. I'm going to keep the name demo Windows Server. And here you'll notice that I have a custom location instead of an Azure region. And this custom location is backed by the HCI cluster. I'm going to pick a VM image from here, and I'm going to choose Windows Server 2022. Note that as part of setting up the VM self-service, an IT admin created an image gallery, which is a locally stored VM images, and they are being projected into the portal, which can now be used by end users like this. For this demo, I will keep the default vCPU and memory, provide a username and password. Next, you'll see that end users are able to add and manage their storage requirements for this VM. So it's very simple for them to add a new disk here. And for this demo, let's keep it at 10 gig. Similarly, they can manage and create their own network adapters for this VM and choose the vSwitch on which this will be running. And once this is done, they can add any tags for ease of management. And after this, they can review and create. And if it all passes, then they can go ahead and create the virtual machine itself. Now, we believe that this is an extremely powerful capability for the DevOps teams to spin up VM instances without owning or maintaining the underlying infrastructure. Observe that any VMs that a user has access to will be all seen in a single pane of glass on Azure Portal. So whether these VMs are running on my own a custom location, or if they were running on inside an Azure region, all of those are easily seen here. The VM self-service capability shown here is still in preview as of August 2021, and several early access customers are using VM self-service and giving us feedback. There are several new capabilities in the roadmap which will enhance the portal-based VM management. So stay tuned. Thank you.
Oh, that was awesome. Thanks, Khalil. With Azure Stack HCI VM self-service, administrators delegate access to other Azure users in Azure AD directory using a consistent toolset with the Azure Portal or the Azure CLI if they prefer. Then users can self-provision VMs and virtual networks. So at this point, I want to take a moment to pause, and I hope you're seeing something here. With Azure Stack HCI, I hope you're seeing the bigger picture here. Azure Stack HCI is an Azure service, and that means consistency, uniformity, and integration. Whether that means management, supportability, billing, services, Azure Stack HCI is something much larger than just hyperconverged infrastructure. And again, because Azure Stack HCI is delivered as a service, it's a simple cost structure that depends only on the number of physical cores that you have. And unlike other HCI vendors, you don't transact one version and in the future have to purchase the next version. Rather, it's an always up-to-date service that keeps getting better and better through regular feature updates over time. Now let's discuss Azure Stack HCI use cases. Azure Stack HCI is a complete solution to deploy cloud-native applications and Azure Arc-enabled services. You can scale Azure Stack HCI down to 2 nodes at your edge and remote locations so you have your VMs, your containers, and Azure Arc-enabled services running on a small form factor with high availability. On the under end of the scale, you can run mission-critical scale-up SQL Server on Azure Stack HCI and achieve industry-leading performance many times faster than other HCI solutions. When it comes to modernizing your data center, you can consolidate your legacy servers and storage devices and reduce power and data center footprint with a future-proof design. Let's take a look. Intelligent Edge and Remote Branch Solutions has been a forte of Azure Stack HCI since day one, because Azure Stack HCI was the first solution to scale all the way down to 2 nodes. In this deployment, and with servers so small you can put them in a backpack or in the overhead storage on a plane, you can deploy an all-flash, switchless solution that is fantastic for the edge. Azure Stack HCI still leads the industry with the only 2-node solution that can survive both a server failure and a drive failure in a 2-node configuration with nested resiliency. Of course, you're going to want to set up a witness resource. This is highly recommended for all clusters. 2-node clusters need a witness so that either server going offline does not cause the other node to become unavailable as well. 3 and higher node clusters need a witness to be able to withstand 2 servers failing or being offline. Azure Stack HCI has the, of course, integrated built-in option to use the Azure Cloud Witness, which can be configured in less than 30 seconds. The amount of data written to the storage account is measured in K, or kilobytes. That's how tiny the storage requirements are per month. The two-node edge solution is very popular, and our partners offer a wide variety of solutions in a wide variety of form factors. Here's a great example of Azure Stack HCI in action. In McDonald's in Belgium, they use Windows 10 Pro for self-service ordering with a two-node Fujitsu Azure Stack HCI on the back end secured by Azure. The partner managing this has an SLA with McDonald's, and the ability to manage these from Azure helps them deliver better service using Azure as the control plane. On the other end of the spectrum, Azure Stack HCI scales up to 16 nodes, supports up to 16,000 terabytes or 16 petabytes with automatic VM load balancing and storage rebalancing. This is all just built in. Yara is a great example of a customer using both Edge and data center class Azure Stack HCI solutions. Yara is working on environmental solutions to protect the world's agricultural, natural resources, and the environment. They've chosen Lenovo Azure Stack HCI solutions for their 28 manufacturing sites. For their Edge environments, they're using a pair of Lenovo MX1020s. They like the Azure integration with a small form factor and, of course, high availability. For their larger sites, they chose the MX3520, which can scale up to dozens of cores over a terabyte of memory with 14 hot swap bays for plenty of flash storage. Now, when it comes to distribution of popular node counts, our Azure Stack HCI telemetry informs us that we're hitting the sweet spot for our customers. 98% of our customers are choosing 8 nodes or less. In first place, we have a virtual tie between 2 and 4 node configurations. In second place, we have 3 nodes. And in third place, we have a significant jump as customers opt for 8 node configurations for modernizing mission-critical workloads. Considering that single servers can be configured with over 100 cores, over a terabyte of RAM, and filled with high-speed flash and networking, a modern server can deliver far greater performance from servers even 5 years old. Azure Stack HCI fits these systems like a glove. Now, up to now, I've demonstrated and managed Azure Stack HCI through Azure. However, what if your Azure Stack HCI loses access to the cloud? What if you're one of our customers who has intermittent network access? For example, you're on a cruise ship, you're on an ocean liner, you're on another vehicle that's out there, or you're just in a location that has spotty network access. No problem. In addition to the Azure Portal, Azure Stack HCI includes a rich set of edge local tools such as Admin Center that is always available. Admin Center can not only manage your infrastructure, but the same console can also manage your Windows Server guests, which complements Azure perfectly. Now, Admin Center has a massive following, with millions of servers under management today, and a top request was to bring it to Azure. So this last year, we did exactly that. We went from complementary and consistent to complementary and integrated. We've brought everyone's favorite Windows Server management tool to Azure, so you can manage Windows Server guests, you can configure roles, features, apps, just as easily in Azure as you can today on premises, and our customers love it. Let's talk mission critical, and that means SQL Server. To show how well Azure Stack HCI performs running mission critical scale-up SQL, our partners at Lenovo performed the following test. In this test, they had 2 Windows Server 2019 VMs, each with 56 virtual processors and 192 gigabytes of memory per VM. Each virtual machine was running SQL Server 2019 with a 450 gigabyte database per VM. They ran HammerDB, which is the leading benchmarking and load testing software for DBs, simulating 5,000 warehouses. Well, here are the results. With a 4-node ThinkAgile MX cluster, they achieved 359,000 batch requests per second. With an 8-node cluster, they achieved 719,000 batch requests per second. This is 2x and perfect linear scaling. With a 12-node cluster, they achieved 1,062,000 batch requests per second, or 2.95 scaling, nearly perfectly linear scaling. It's exceptional SQL performance like this, coupled with a 50% cost reduction that led Nissan to switch from Oracle to SQL Server on Azure Stack HCI. Now, in addition to performance, it goes without saying that Azure Stack HCI is the best place to run Windows Server and SQL Server for reasons like support, performance, and more, such as built-in native disaster recovery with Sledge clustering. Mission-critical workloads means high performance and high availability with the option for disaster recovery. With Azure Stack HCI, that's no problem. Azure Stack HCI provides a flexible solution that offers both synchronous and asynchronous replication options. This provides a solution whether you want to span a campus, cities, or span the globe. Both active-active and active-passive modes are supported. Another aspect of mission critical is supportability, and there's still a lot of critical apps out there running on legacy Windows Server releases. For Windows Server 2008 and R2, extended security updates are coming to an end in January 2023. For those folks who still need just a little bit more time for Windows Server in 2008 and R2, we will now provide 1 additional year of free extended security updates. This is only available on Azure and Azure Stack HCI. For Windows Server 2012 on R2 and SQL Server 2012 on R2, we are about 2 years from the end of support date. After that, we will offer paid extended security for Windows Server and SQL Server 2012 and R2 like we did for Windows Server 2008. Or you can receive these ESUs at no additional charge for 3 years when you migrate your apps to Azure or Azure Stack HCI. So, Gartner, I want to take a moment, a little aside here, to make sure we really understand this, because this is actually a very important note, and not a lot of people understand this. The scenario is really simple. I've now run into multiple customers who could have easily purchased multiple all-flash 4-node Azure Stack HCI clusters for what they're spending on extended security updates. Okay, let's put this perspective. Large organization, massive on-premises infrastructure, they're spending millions on extended security updates. Okay, well, they could have used that same spend and purchased Azure Stack HCI. The result would have been a massive performance improvement, Azure integration, a secure platform, and those same exact extended security updates. So the question I keep asking customers is, would you like to A, pay for ESUs on your existing infrastructure, or use that same spend on new Azure Stack HCI solutions and get those same ESUs included? Now, the first thing I always hear from my customers is, well, wait a minute, where's the proof? Okay, here's the proof. It's right here. Here's the link. You scroll to the FAQ and it says clearly, extended security updates included with Azure Stack HCI. So here's an important tip you may want to include in your note. Another really awesome feature for mission critical in the edge is automatic VM activation on Azure Stack HCI. With traditional activation, you have to manage keys and licenses for each VM. With AVMA, you apply your Windows Server data center key to the host, and it will automatically activate all your Windows Server guests. This means you can activate VMs that aren't even network connected, and you no longer need to track individual keys and licenses for each VM. AVMA makes edge deployments even easier. So, we've discussed Azure Stack HCI as an Azure service and Azure Stack HCI use cases. Let's discuss Azure Stack HCI as the vehicle to run Azure services on premises with AKS on HCI. So to do that and set some context, let's start with AKS, the Azure Kubernetes Service. Azure Kubernetes Service simplifies deploying a managed Kubernetes cluster in Azure by offloading the operational overhead to Azure. As a hosted Kubernetes service, Azure handles critical tasks like health monitoring and maintenance. Developers love AKS because it allows them to focus on the app. Since Kubernetes masters are managed by Azure, you only manage and maintain the agent nodes. Thus, AKS is free. You only pay for the agent nodes within your clusters, not for the masters. Now, as a managed service, not only do you benefit from the simplicity, but you also benefit from all the learnings of Microsoft engineers building AKS, thousands of engagements with enterprise organizations, and deep integration with the open source community in the form of comprehensive best practices and recommendations for running AKS-based applications and services. With AKS, you can mix Windows and Linux applications in the same Kubernetes cluster with consistent monitoring, experience, and deployment pipelines. Security is part of AKS by design, with multiple layers of hardening and isolation, and in addition, we've published a security baseline for AKS, which contains recommendations that will help you improve the security posture of your deployment. AKS is also fully supported by Microsoft Support, which is made up of certified Kubernetes experts who can help diagnose and troubleshoot any issues you may run into. The key part of AKS is that it's a managed service. You don't set this up. You don't provide the compute, the storage, and the very complicated networking infrastructure. You don't secure it. You don't manage the lifecycle. When a new version of Kubernetes is released, Microsoft handles all of the lifecycle management for you. So with this in mind, we wanted to deliver a familiar experience on premises, and thus AKS on Azure Stack HCI. With AKS on Azure Stack HCI, you can rely on easy-to-use workflows so you and your team can get up and running quickly. In less than an hour, your Azure Stack HCI clusters will be ready to host your cloud-native apps. Under the hood, the deployment takes care of everything that is required to bring up Kubernetes and run applications. This includes core Kubernetes, container runtime, networking, storage, security, and operators to manage underlying infrastructure. Scaling the cluster up or down by adding, removing nodes, or deploying cluster updates are equally quick and easy. AKS on Azure Stack HCI is the best platform for running .NET Core and .NET Framework applications, whether your apps are based on Linux or Windows. The infrastructure required to run your containers is included in the solution and fully supported by Microsoft. For Windows containers, AKS offers an industry-leading solution with advanced features like group-managed service accounts for non-domain joined hosts, Active Directory integration, and Windows Admin Center-based application deployment, migration, and management. You can modernize your Windows apps more easily than ever before with AKS on Azure Stack HCI. And keeping your infrastructure secure is very important to us. AKS on Azure Stack HCI is always up to date, just like any Azure service. Security updates for the entire solution, including core Kubernetes, network and storage drivers, Linux and Windows container hosts, and other binaries delivered by Microsoft. To show you just how quickly and easily to deploy AKS on HCI, here's a demo from my colleague, Matt McSpirit.
So we'll first deploy the AKS on Azure Stack HCI management infrastructure using Windows Admin Center. So first we'll go into system checks. We'll provide some appropriate credentials, and then Windows Admin Center will check the system to ensure everything's set up correctly, and we'll apply those configuration changes if required. We'll then ensure that Windows Admin Center can connect to the environment correctly using CredSSP, and we'll move on to setting up our host. We'll define our storage location for our images and our virtual machines. We'll define our network settings, in this case DHCP, and apply an IP address range that will be used by our Kubernetes clusters. Then we'll configure the Azure registration, which will pull in my login credentials from Windows Admin Center. I'll define a subscription, create a new resource group that's going to hold our registration information in Azure, and a region in Azure that's going to contain that resource group. We'll review our settings that we've made, ensure everything's correct, and apply that configuration. And that's going to just take a few moments. Once that's complete, we can move on to the deployment of AKS on Azure Stack HCI's management infrastructure. And as you can see, in this case, it took around 12 minutes. And with that completed, we can see all the information about our AKS on Azure Stack HCI infrastructure, and we're ready to move on to deploying new Kubernetes clusters to run our workloads.
Oh, that was great. You just saw Matt set up the Azure Kubernetes service through an easy-to-use workflow. Now you may be wondering, what happens when there's an update to Kubernetes? Folks that try to deploy and manage the Kubernetes lifecycle on their own often run in this challenge the first time a patch comes out. With AKS on HCI, Microsoft has you covered. We'll deliver the update to you via Microsoft Update and update your Kubernetes deployment without downtime to your apps. At this point, Matt has just set up the AKS on HCI service, so now it's time to create an application cluster for your apps. I'm going to pass it back to Matt. Matt, here we go.
With our management infrastructure deployed, we're back in Windows Admin Center, ready to start deploying our first Kubernetes cluster to run our workloads. So I'm going to start by providing some basic information. I can optionally integrate with Azure Arc for management, security, and governance of our Kubernetes clusters from the Azure Portal. I'll provide some basic information here: subscription, resource group, and a region. I'm going to scroll down and provide some credentials to connect to our AKS HCI management infrastructure. That's going to do some validation. It's going to present us with some version options. I'm going to enter the name of my cluster that I'm going to deploy. And I can also define sizes for my primary node pool. Now for our actual workload clusters, we're going to define 2 node pools, a Linux pool with a single Linux worker node of a certain size that we can define. And I'm going to repeat that process to create a Windows pool as well, again with just a single node at this time. We can optionally choose to integrate with Active Directory. In this case, I'm going to skip that part. And under networking, we've now got flexibility to choose between Flannel and Calico network options and select or add a new virtual network that we wish to deploy our Kubernetes cluster into. With all that configured, we can start the creation process to create this cluster. And as you can see, it didn't take too long, and we're now ready to start deploying our Kubernetes workloads into this environment. Back on the dashboard page, we can also connect directly to Azure, in particular this new Azure Arc instance of this Kubernetes cluster, ready to start integrating with GitOps, Azure Policy, and more.
Wow, that was super cool. So Matt just created a Kubernetes cluster to host applications. During the process, he enabled Arc integration, created Windows and Linux node pools, and configured his network with a load balancer. When the process was completed, a link was provided taking him right to Azure where he could apply Azure Monitoring and Azure Policy to this app. Now, let's show you how Azure Policy can deliver tremendous benefit to your AKS deployments on Azure Stack HCI. I've asked Abhilasha to demonstrate how Azure Policy can be used with AKS on Azure Stack HCI. In this demo, she's going to show you how to solve a critical real-world issue.
Hey everyone, I'm going to show you a demo of how easy it is to use Azure Policy for Kubernetes on top of AKS on Azure Stack HCI. Let's imagine a scenario. You're a developer and you've deployed an application across multiple AKS on Azure Stack HCI clusters. Let's take a closer look at the YAML file. In this YAML file, you're using 2 images, one for the front-end UI and one for the back-end database. You've recently found out that the database container image has a critical bug and you need to stop using it. How do you find out which AKS HCI clusters are using this buggy image? You don't have to go to every cluster to do a manual check because Azure Policy does that for you. Let us go to the portal and create a policy definition that will help you identify all the application instances where this image is being used. In previous demos, you saw how you can connect your AKS HCI clusters to Arc. This Arc connected cluster already has policy enabled on it. Click on Policies and then click on Assign Policy. On this page, you can set the scope. I've set it at a subscription level, and you can choose a policy definition. Then you can click on Next and then choose the image that you want to allow, that is the image that does not have the critical bug. And then click on Create. This policy applied at a subscription scope will evaluate the AKS HCI clusters in your subscription and will flag the ones that have an application running that with unapproved images. After some time, you can see that 2 of your AKS HCI clusters have the buggy image. You can also click into the clusters to get a more detailed view of the containers in question. This is how you can use Azure Policy to ensure that your applications and Kubernetes clusters are secure and compliant. For more information on built-in policies like this demo, and for more information on how to set up Azure Policy for Kubernetes on AKS on Azure Stack HCI, visit aka.ms/akspolicydoc.
Thanks, Abhilasha. That was great. Think about what you just saw. Abhilasha just solved a real-world problem where a Kubernetes application is deployed, and you later find out that one of the images has a serious flaw. How do you hunt down every app and every instance of this image? With Azure Policy, Abhilasha created and deployed a policy that was pushed out to every AKS deployment in this subscription to locate every one of these bad images so this could be remediated. Okay, let's take a step back and look at the high-level Azure Stack HCI architecture. It starts with a rich hardware ecosystem with over 250 partner solutions that have been tested and validated to ensure an optimized and supported solution. Next, we have the Azure Stack HCI operating system. Here, we have combined 25 years of experience delivering on-premises Windows Server along with Azure technology from our hyperscale public cloud to deliver a hyper-converged solution that is uniquely optimized for hybrid scenarios. Here, you can run your Linux and Windows virtualized apps like your custom line of business apps, SQL Server, SharePoint, Exchange. This covers all your existing apps. Now, with AKS on Azure Stack HCI, we have you covered for your new cloud-native apps. This is Kubernetes conformant, so when your devs update your apps, these will get pushed to all your AKS on Azure Stack HCI endpoints. You can run Azure Arc-enabled data services, which is always current, provides elastic scale and unified management, as well as any other Arc-enabled services, such as app services, machine learning, and a lot more to come here. This empowers your developers to run traditional apps, cloud-native apps on this infrastructure using a variety of frameworks. And all of this is fully integrated with the Azure Arc control plane. What this means is you can develop on AKS and deploy to the edge with AKS on HCI. Now, I just mentioned Azure Data Services. Let's cover some of the major benefits. First, customers will always be current, meaning updates and upgrades are fully automated and the deployment is controlled by policy. Customers will gain unique and cloud-proven innovation ahead of any other hybrid cloud offering, and the evergreen SQL with no end of support through Azure SQL Database and the hyperscale deployment option for Azure Database for PostgreSQL. Second, we're bringing cloud elasticity on premises so you can optimize performance of data workloads with the ability to dynamically scale up and down and scale out without application downtime. Folks, this is here right now. Moreover, by connecting to Azure, customers will gain unified management. You can see your data services running on premises along those running in Azure through a single pane of glass using familiar tools like Azure Portal, Azure Data Studio, and Azure CLI. In addition to Azure Data Services, I want to alert you to Azure App Services. Azure Arc-enabled app services deliver the Azure services you're using today, like application services, data services, ML, to any environment. For example, today's thousands of developers are using Azure's suite of application services, including app services, functions, logic apps, and honestly, developers love these services. They're tailored to real-world app patterns, loaded with unique features and optimized for developer productivity. With Azure Arc, you can now run these same services on premises, on the edge, or in even other clouds. When combined with the use of Arc-enabled data services like Azure Postgres and Azure SQL, applications and their data can now run anywhere using fully managed cloud services, an industry first. An important thing to note is that the way you deploy does not change. You use your existing tools and practices and benefit from a seamless, consistent experience. And let me provide a customer example with SKF. SKF is the world-leading manufacturer for rotation tools and services, supporting reliable, efficient, and environmentally sound industrial operations across many verticals. The company has embarked on a global effort to modernize and transform their 106 factories so they can bring innovative solutions to the industrial world rapidly. SKF chose to partner with Microsoft because Azure offers hybrid solutions that cover the entire stack, from modern infrastructure with Azure Stack HCI to consistent data management with Azure Arc-enabled SQL managed instances to edge computing needs on existing machines with Azure SQL and IoT Edge. For SKF, the linchpin to deploying new Azure Stack HCI solutions was having Azure as the management plane and the ability to deploy Azure services on premises like AKS Data Services and Azure SQL Edge. While we're delivering more services to delight developers at the edge, we also providing GPU acceleration for AI inferencing and ML workloads with Azure Stack HCI. With support for GPUs in Azure Stack HCI, this enables support for ML and GPU-dependent applications via DirectX for Windows containers. By enabling GPU acceleration for DirectX, we're also enabling GPU acceleration for the frameworks built on top of DirectX. One such framework is Windows ML, a set of APIs providing fast and efficient AI inferencing capabilities. With GPU acceleration in Windows containers, developers now have access to a first-class inferencing runtime that can be accelerated across a broad set of capable GPU-accelerated hardware. Here's a quick peek of enabling GPU for highly available VMs from my colleague Prasid.
In Microsoft Azure, we use partitioning technology built on SRIOV to securely deliver GPU acceleration to virtual desktops and other virtual machines. Soon, you'll be able to do the same on your premises. In Windows Admin Center, I'll connect to my 2-node Azure Stack HCI cluster. This demo uses 2 of the Dell AX640 systems, and each node in this cluster has 1 GPU, an NVIDIA Tesla T4. Let me show you what this looks like with this pre-release build of the GPUs tool coming soon for Azure Stack HCI. From here, I can see all of the GPUs across every host in my cluster, including information such as model, manufacturer, physical location, driver version, and most importantly, assignment status. From this page, I can easily select a GPU and perform critical operations such as mounting and dismounting to the physical GPUs running on these hosts. With Azure Stack HCI 21H2, we introduce assigning GPUs to highly available virtual machines with the concept of GPU pools. A GPU pool is a collection of 1 or more GPUs. Previously, you would assign a physical GPU to a virtual machine, locking that virtual machine to only that host and thus preventing high availability. With Azure Stack HCI, instead of directly assigning a GPU to your VM, you assign a GPU pool to your VMs. GPU pools of the same name that consist of the same specifications of GPUs on each host will deliver high availability of your VMs. Let's take a look. Here, I can create a new GPU pool, one on each host of my cluster, both with the same name, Test Pool 3. Now, I can click on one of these GPU pools, a pool on node 1 in this case, and assign it to a highly available VM running on that host. In this case, Windows Admin Center will use discrete device assignment to assign my NVIDIA GPU to this VM, Test 4. Now let's confirm that it is indeed highly available. I'll navigate to the virtual machine page in Windows Admin Center and migrate Test 4 to the other node in this cluster, Node 2. I'll now start this VM and navigate back to my GPUs page. Here you can see that Test 4 is now assigned to the GPU pool on Node 2 when it was previously assigned on Node 1. This makes attaching a GPU just as easy as attaching a virtual hard disk.
Wow, that was really cool. Thanks, Prasid. Now, one area we haven't discussed yet is security. Our customers tell us, ransomware keeps us up nights. We don't want to be next. We understand that concern. A recent survey finds that more than 1/3 of organizations worldwide have experienced a ransomware attack or breach. Here's another recent article where dozens of hospitals and clinics are canceling surgeries and diverting ambulances because a ransomware attack knocked out access to virtually all their operations. Ugh. At Microsoft, we have a strategy to protect, defend, and prevent. Protect with hardware root of trust, defend against firmware level attack, prevent access to unverified code. Let's start with firmware protection. 83% of all businesses have experienced a firmware attack in the past 2 years. The goal of firmware attacks is simple. Attack the system before the OS is started and implant malware. Let's discuss what one of these attacks looks like. Here's an anatomy of the Robinhood ransomware. Robinhood ransomware is distributed as a packaged executable that contains multiple binaries. One of the files is a gigabyte driver, gdrv.sys. This driver has a vulnerability that could allow elevation of privilege, enabling an adversary to gain kernel privileges and then disable kernel mode signing to facilitate the loading of an unsigned driver. The unsigned malicious driver is then used to disable security products from the kernel. The Robinhood ransomware then goes on to encrypt files and demand ransom from the victims. Robinhood is not an isolated threat leveraging a vulnerable driver to achieve elevation of privilege. In the last 2 years, the Defender ATP research team has seen a rise in the use of vulnerable drivers by adversaries ranging from commodity malware to nation-state level attacks. The good news is we have a solution and proof of its effectiveness already in Secured Core PC. Secured Core PCs provide more than twice the protection against infection. That's why we're introducing industry-leading Secured Core Server with Azure Stack HCI. A Secured Core Server is a modern device that comes with the highest level of hardware, software, and identity protection ready right out of the box. With Secured Core Server, it protects boot up with hardware root of trust. Secured Core servers use industry-standard hardware root of trust coupled with security capabilities built into today's modern CPUs. With Secured Core Server, it defends against firmware-level attack. Secured Core servers use hardware-rooted security in the modern CPU to launch the system into a trusted state, preventing advanced malware from tampering with the system and attacking at the firmware level. With Secured Core Server, it prevents access to unverified code. Once the CPU is brought up safely, the operating system takes control. Hypervisor-enforced code integrity ensures that all code in the OS kernel is trustworthy. To help raise awareness, we're making Secured Core security obvious and visible right here in Windows Admin Center. We're going to highlight security features and work together with the industry to make these Secured Core safeguards the new normal for servers, which starts with Azure Stack HCI integrated systems. Azure Stack HCI is available from partners in 2 forms: validated nodes and integrated systems. Validated nodes include extensive multi-node validation testing with over 5 years of support provided by the partner. Integrated systems build on the validated node requirements and add much more, such as Secured Core Server platforms, orderable multi-node solutions, full stack updates. We've actually worked with all of our OEM partners, Dell, HPE, Lenovo, DataOn, and more, where they provide a firmware driver recipe. So when you actually update through Azure Stack HCI, it goes to the vendor and gets the exact right recipe of drivers and firmware, so there's no hunting around and looking for it. And it's all delivered with one-click rollout. And of course, a joint support agreement for seamless handoff and so much more. As I mentioned earlier, the same team that builds and deploys the Azure host builds and delivers Azure Stack HCI. With Azure, we innovate, test, and develop new features that are deployed to the Azure fleet. We then deliver that unique Azure host innovation to our users. I want to give you a peek of new Azure innovation that will be available very soon in Azure Stack HCI. Kernel Soft Reboot or KSR. KSR is an Azure native technology we developed to safely skip the pre-boot sequence and hardware post to literally save millions of minutes every month. With the traditional reboot process, when the system is down, the OS hands off control to the firmware. The firmware then reinitializes the system, goes through post, and then reinitializes all the drivers before handing control back to the new OS. The firmware transition in post-process can take several minutes in server-class systems. Since the hardware configuration has not changed between a reboot, platform reinitialization is not always necessary, and KSR basically takes advantage of this. KSR skips handing control to the firmware and hands control to a special driver. This driver jumps to the new kernel, which performs initialization of drivers and sets the OS just up like it just would on a normal boot. Sounds complicated? Let me just show you. On the left is a normal reboot, and on the right is the KSR, the kernel soft reboot, with the exact same hardware. These are both Dell R740XD servers. You can see that with KSR, the OS on the right returns very quickly, with the Azure logo coming right up and the whole process completing in, 19 seconds. The normal reboot, which includes the full pre-boot sequence and power on self-test, takes more than 10 times longer. In fact, to save time here, we sped things up a few times to show you that the normal reboot takes almost 4 minutes. This makes a huge difference in minimizing the impact of software updates. In short, Azure Stack HCI is over 10 times faster than a classic reboot with KSR. Next, let's discuss networking. Deployment and operation of hyperconverged infrastructure networking can be a complex and error-prone process. Due to the configuration flexibility provided with the host networking stack, there are many moving parts that can be easily misconfigured or overlooked. How many NICs do you have? 2, 3, 5? Which NICs do you use for storage, for compute, management? Do you team these NICs? What optimizations do you enable? Configuration consistency across HCI cluster nodes is important, as it leads to a more reliable experience. In Azure, we deploy millions of machines through policy-driven networking, and now we're bringing intent-driven networking to simplify Azure Stack HCI configurations. So what is intent-based networking? Well, in short, an intent is how do you intend to use the physical adapters in your system? For example, management adapters are used for management access to the server nodes themselves. Compute adapters are used to connect virtual machine traffic to the actual physical network. Storage adapters are used for the SMB traffic like storage spaces direct and the underlying storage. Network ATC can help reduce your host networking deployment time, complexity, and errors. It will deploy the latest Microsoft validated and supported best practices. It'll ensure configuration consistency across the cluster, and it will eliminate configuration drift. Sounds pretty awesome, huh? Well, let me show you just how cool Network ATC really is. Here we have an 8-node cluster. Each server has 2 100 gigabit Ethernet NICs. We're going to create a new intent that both NICs handle compute and storage. This is one line of PowerShell. By the way, we'll get a nice Admin Center UI as well. Through the process, it validates the requirements are met, like symmetric NICs. Symmetric NICs means NICs of the same make, model, speed, and configuration in every server. We give it about 60 seconds, and voila, all done. It created a converged switch on every node. It automatically configured teaming. It determined the right offloads. It set quality of service using Microsoft's best practices. It named all of the virtual networks so you can see which ones are being used for what purpose, like storage. And you can see we just configured an 8-node cluster, all of the networking just like that. With Network ATC, all you have to do is point at the NIC and tell you what it wanted to do, and it handles the rest. Now, I'm really excited about this new feature coming to Azure Host and Azure Stack HCI at the same time in fall 2021. This is literally just a few weeks away. Dynamic processor compatibility. Let me explain why this is important. When you live migrate virtual machines between servers, you need to have homogeneous processors. Not only the same manufacturer, but the same model. Sometimes it can be difficult acquiring the exact same model. For example, what if you want to upgrade a few months later and it's no longer available? For this reason, we created processor compatibility mode. Now, in the past with static processor compatibility mode, the virtual processor was normalized to an older Pentium-era processor for compatibility. This means that newer processor instruction sets were hidden, meaning that the guest operating system and application software could not take advantage of new processor instruction set enhancements to help apps and VMs deliver the best performance. Now, this was a trade-off. We knew this. But the trade-off was performance for live migration mobility. And quite honestly, customers have to have live migration mobility, so they were willing to accept that trade-off. Well, dynamic processor compatibility gets rid of that trade-off. You now get maximum performance with live migration. Dynamic processor compatibility mode provides new functionality that calculates the common denominator of the CPU features supported by the nodes in the cluster and updates the existing processor compatibility mode on a VM to use this dynamically calculated feature set instead of the old hard-coded static feature set. In Azure Stack HCI environments, the new processor compatibility mode ensures that the set of processor features available to VMs across virtualization hosts match by presenting a common capability set across all servers in the cluster. This means each VM receives the maximum number of processor instruction sets that are present across all the servers in the cluster. This is a transparent process. It occurs automatically, is always enabled, and replicated seamlessly across the cluster. Here's an example. Suppose you have a cluster with a second generation Intel Xeon Scalable processor and you want to add more capacity. You can scale out by adding third generation Intel Xeon Scalable processors within the same cluster. Azure Stack HCI will determine every processor feature shared by both processors and deliver live migration compatibility with full performance, automatically and transparently. Next, let's talk about Windows Server 2022 Data Center Azure Edition and Azure Stack HCI. Windows Server 2022 Data Center Azure Edition includes all the Data Center Edition features, and then adds additional Azure, Azure Stack HCI, and Windows Server innovation. This new Windows Server Azure Edition features, again, are available with Azure Stack HCI. And this innovation starts with hot patching. Hot patches update in-memory code of running processes. No process restart or reboot is required, and I want to point out that this currently requires server core. This is a hot feature, and I'll show you this in just a sec. Next, we have SMB over QUIC. SMB over QUIC introduces an alternative to the TCP network transport, providing secure, reliable connectivity to edge servers over untrusted networks like the internet. SMB over QUIC offers an SMB VPN for telecommuters, mobile device users, and high-security organizations. The server certificate creates a TLS 1.3 encrypted tunnel over UDP port 443 instead of TCP port 445. SMB behaves normally within the QUIC tunnel, meaning the user experience doesn't change. SMB features like multi-channel, signing, compression, continuous availability, directory leasing, and so on, these just all work normally. SMB over QUIC is great for edge devices so they can access a file server. It's also great for telecommuters, mobile, and hybrid workers with Windows 11. Finally, we have Azure Extended Networking, which is designed to solve the challenge of moving apps to the cloud and need to maintain the same IP addresses. This is about providing a path to IP independence. Azure Extended Network enables you to stretch an on-premises subnet into Azure to let on-premises virtual machines keep their original on-prem private IP addresses when migrating to Azure. The network is extended using a bidirectional VXLAN tunnel between two Windows Server 2022 Data Center Azure Editions VMs acting as virtual appliances. One running on premises and the other running 22 Data Center Azure Edition in Azure, with each also connected to the subnet to be extended. Each subnet that you're going to extend requires one pair of appliances, and multiple subnets can be extended using multiple pairs. In short, Azure Extended Networking provides a path to IP independence. Okay folks, time for my last demo, hot patching. Hot patching is a new way to install updates that doesn't require a reboot and won't interrupt workloads running on your server. Before we start, let me describe the demo environment. On the right, I have a new Windows Server 2022 core VM where I'm going to manually install hot patch updates. For comparison, on the left side, I have a Windows Server 2022 core VM and I'm going to install a comparable latest cumulative update, or an LCU. This is a traditional update. On each VM, I've queued up two massive file copies, the same exact file copies as sample workloads. On top, there's a timer so we can track the status of the patching installation. Now, I'm going to start off the patch installation on each VM. First, the traditional LCU, I'll even give it a little head start, or the latest cumulative update. Okay, so that's installing. Next, on the right-hand side, we've got the hot patch update. So we're going to install, and the hot patch is done. As we can see, the file copy continues uninterrupted. On the left side, you can see that the traditional LCU is still going. In case you missed the first hot patch, let's do it again. Don't blink, you may miss it. Let's run a second hot patch, and we're going to go ahead and install that. One second here. And we're installing it, and just like that, we are done. And you can see zero impact to the running workload. Now, one of the great advantages of hot patches is that changes are made in memory. This means that even running processes will pick up the new updates immediately and without interruption. Now, we installed these updates manually for the demo so you could just see how impactful this technology is. But in reality, we're also hooking this up with update orchestration in Azure with Azure Auto Manage. So you can see this is still taking some time, so let's speed up the video so we can get to the completion of the traditional update. You can see that this update also requires a reboot to complete the update process. So if I reboot now, it's going to interrupt the file copy. So I'm going to wait for the file copy to complete here. Let's speed ahead to the end. Yeah, you can see it's taking a little bit more time here, and perform the reboot. So that was a quick demo of hot patching with Windows Azure Edition that will also be available on Azure Stack HCI. So to quickly summarize, we demonstrated Azure Stack HCI as an Azure service with Portal integration, fleet management, Azure Monitor Integration, and Azure Stack HCI Insights. We covered support and demonstrated VM self-service. We discussed Azure Stack HCI use cases with customers and showed how Windows Admin Center has been integrated into the Azure Portal to delight our customers. We discussed mission-critical data center modernization, showed off the results of SQL scaling tests, and covered the tremendous ESU options with Azure Stack HCI. We drilled into AKS on HCI with numerous demos on AKS Setup, Kube Cluster Setup, and Azure Policy integration with AKS on Azure Stack HCI. We reviewed the high-level Azure Stack HCI architecture and explained how AKS on HCI is a vehicle for delivering Azure services on-premises. We reviewed Azure Stack HCI industry-leading security and tied off the presentation by showing that Azure Stack HCI delivers unique Azure host innovation like hot patching on-prem. With Azure Stack HCI, again, I hope you're seeing the bigger picture here. The combination of Azure, Azure Arc, and Azure Stack HCI is unparalleled. It provides manageability at scale, automated security and governance, app innovation and agility, Azure services on-premises, consistency, uniformity, and integration. Finally, this is just the beginning of delivering cloud services on premises. What cloud services would you like to see on premises? It's probably on the way. Thank you for joining me today.